Hello, everybody. This is the last video for section 2.4, and it is about a very important topic called LU factorization. Now, LU factorization, I just need to ask you to bear with me because I'm going to explain where it comes from, and it may seem tedious and not worth it, but it is very, very, very worth it. And what LU factorization will do for us will make it much, much quicker and easier to solve systems of linear equations. So first of all, what is an L? What is a U? L stands for lower and U stands for upper. A lower triangular matrix is a matrix where all the non-zero numbers are in the lower corner. And an upper triangular matrix is one where all of the non-zero elements are in the upper part of the matrix. So in a lower triangular, you have the non-zero numbers down here, and you have the zero numbers up there. You have only zero. You have only zeros up on top, and anything that's not zero has to be in the bottom, and vice versa. Now, by the way, if you have a diagonal matrix or a zero matrix, that's okay. It's okay if these A's are all zeros, as long as these zeros here are not A's or not non-zero. Anyway, what is LU factorization? Funny you should ask. So LU factorization means you have an n by n matrix, A, and you want to write A as a product of a lower triangular and an upper triangular. That's called the LU factorization. Now, this may seem weird and crazy and pointless, but it is very, again, it is very, very pointful, and we're going to see an example as we get to the at the end of this. Anyway, let's continue. Here's two examples of LU factorizations. A is the matrix 1, 2, 1, 0. If you multiply this matrix times that matrix, I'd like you to do that by hand to see that it actually works. You will get A. Now, this is lower triangular because the non-zero numbers are on the bottom, and this is upper triangular because the non-zero numbers are on top. That's why we say LU. So this is A, and L is that guy right there, U is that guy right there, and PAL. Now here we have a 3 by 3. We have a 3 by 3. A is 1, negative 3, 0, 0, 1, 3, 2, negative 10, 2. So here we have a lower triangular because the non-zero numbers are all down here. And here we have an upper triangular because all the non-zero numbers are up here. So notice that A is equal to L times U. Now, again, I'd like you all to do this. I'd like you all to do this multiplication by hand. Why do I always ask you to do things by hand? You have calculators, and there's so many ways you can do these. There are programmable calculators that are multiplying matrices for you. There are websites and apps and who knows what, to multiply. The reason is because when you do things by hand, you get a certain feel for why things work and what's going on. You just get a certain feel for things that you just don't get otherwise. Anyways, let's continue. But remember this right here. In fact, let's remember this matrix right here. And I'm even gonna take a little snippet of it. This is called a Snippet Tool, and it snips things. I'm just gonna hold on to that. So we may or may not refer back to this. Anyways, these are all things where they use LU factorization for real life phenomena of fluid dynamics and such. Anyway, so I just sort of gave you an LU factorization like for free, you know what I'm saying? But how would you actually find an LU? How would you find an LU factorization? Well, you actually pretty much know most of the techniques. What you're going to do is you're going to take the matrix A and you're going to put it in upper triangular form. Now, upper triangular form is going to be similar to putting it in row echelon form, but actually will be even a little bit less demanding. And I'll show you what I mean by that. Meaning that you don't have to have all ones down the main diagonal. You have to have all zeros down here like row echelon, but you're not required to have ones on the main diagonal. Nothing wrong if you do, but it's not a requirement for an upper triangular matrix. Anyways, so what are we going to do? So we're going to do the same things we do to put a to put a matrix into upper triangle, excuse me, into row echelon. We want to get rid of that 2. We want to turn that 2 into a 0. So we add -2 times the top row onto the bottom row. That becomes a new bottom row, which is what I'm doing right here. And that's how I get this guy right there. Then I want to get rid of that. I want to get rid of that -4. So I add 4 times the middle onto the bottom, and which is what this step is. But notice that adding this step here corresponds to this matrix, and this step here corresponds to that matrix. So if I take the matrix A, multiply by E1, and then multiply that by E2, I'm going to get this last upper triangular matrix. And so A times E1 times E2 equals U, which is that the name of that upper triangular matrix. And of course, if I multiply by the inverses here, I get A is equal to E1 inverse times E2 inverse times U, because the product. Now, what I'm trying to say here is that the inverse of E1 is just making that a +2, and the inverse of E2 is just making that a -4. So notice that the inverse of a lower triangular matrix is also lower triangular. So E1 inverse times E2 inverse, these are 2 lower triangular matrices, and the product of lower triangular matrices itself is going to be lower triangular. And this is something that you could see when you multiply when you multiply that by hand, you see it very clearly, and you'll see exactly why it's happening. And you get this guy right here, which is lower triangular. Notice that the 2 and just goes right there, and -4 goes right there. Everything's very awesome here. So we're in good. So this product of these 2 lower triangular matrices multiply out to a lower triangular matrix, but notice that this product is a lower triangular times U, which is upper triangular. So we actually have the LU factorization. In fact, we saw it. This is the thing I skipped. This is the lower triangular. That's the upper triangular, and that's what we just got with this process. Now, we're going to use this to our great advantage. And that's what it says here. Notice that this is the same LU factorization from 5b, which is what I just showed you on the snippet. Okay, now, let's look at this right here. Now, believe it or not, we're going to use this to solve equations of the form AX equals B, where A is a coefficient matrix, X is the variables, and B is the constants. And we're going to do an LU factorization on A. So now I'm going to show you what the process is of using an LU factorization to solve a system of equations. So first, I'm going to show you the theory of it, and then we're going to actually put it into practice. And it just works out awesomely. Okay, so first we take the matrix. First we take the matrix A and put it into LU factorization, which we just learned how to do. Then we take the U from the LU factorization, multiply it by the X variables, and I'm going to get a column matrix, and we're going to call that capital Y, or bold Y, I should say. Now, I don't know what bold Y is yet. I don't know what the X's are yet. I don't know anything yet. But once I have this matrix Y, I'm going to multiply Y times the lower times the L of the LU factorization to get B. Now I know what B is because that's going to be given as part of the problem. That's going to be the constants. I know what L is because I did the factorization of A, and this is going to help me solve for Y. And this is going to, now what's the big deal about this? So it's just another, so I took one system of equations to solve. Now I have a different, so all I did is now have a new system to solve. In fact, once I solve that, I'm going to get Y, And I'm gonna go back to this guy right here, where ux equals y. Now that I know y, I'm gonna solve for x. So what's the big accomplishment? I've well, let me just again go through why it works. Now, this new x is going to be the solution, because if I have a times x, well, a is equal to lu, but ux is equal to y, and ly is equal to b. That's the way I defined and set everything up. But so it sounds like I'm crazy. Well, we know I'm crazy, but it sounds like this is nuts, because I'm taking, what did I accomplish here? I had one system of equations, and now I have to solve two systems of equations. So what have I done? It sounds like I've made things worse, not better. Well, the answer is that these systems are going to be super duper much easier, because when the coefficient matrix of a system of equations is either upper triangular or lower triangular, then the system solves lickety split. And this is something you see. That's why we put coefficient matrices into row echelon form, because they're they are upper triangular. Anyway, let's do an example. So here we have a system of equation. X1 minus 3x2 equals -5. X1 plus 3x2, 3x3 equals -1. 2x1 minus 10x2 equals -20. Now, if you notice, the coefficients here is the good old, this is the good old A matrix that we've been dealing with this whole time. The coefficients here are 1, -3, 0, 0, 1, 3, 2, -10, 2, which is the A that we've been dealing with this whole time. See, it's you see that from my little snippet. See, there was a madness to our method. So we already know the LU factorization. We already did it. That's L and that's U right there in front of us. Now I want to take my U, which is the U right here, and I want to well, I'm sorry. First, I'm going to take the L. You actually do this step first, even though I mentioned this step second. You actually do this step first. First, why? Because here I have two unknowns. I don't know the x's, I don't know the y's. But here I only have one unknown, so we're going to solve the one unknown. So I'm going to take my L, which is this matrix right here, multiply it by my y column, which is just these three variables, and set it equal to the constants from that equation, 5, -1, -20. See, it's the same constants that we had right up here on top. Now, but this is actually going to be very simple to solve, because this is saying that y1 equals -5, y2 equals -1. And once I know y1 and y2, I get y3 super fast. And that's why this is so simple. See, y1 is -5, y2 is -1, and once I have that, I just plug it in here, and I wind up solving. I get y3 equals -14. So my y solution is going to be -5, -1, -14. Now I'm going to go do my ux equals y and solve for x. So ux equals y, and I solve for x. So that's the u from my LU. That's the x's, which is the x's here is what I really want. And this is the y constants that we just solved for. Well, again, 14x3 equals -14. So x3 equals -1. Well, if x3 equals -1, this tells me x2 minus 3 times plus 3 times -1 equals -1. You see what I'm saying? So that tells me that x2 is going to be equal to 2. Again, it comes out very simple, very, very quickly. And once I know that once I know x3 and I know x2, I can easily solve for x1. I get x1 minus 6 equals -5, which is to say x1 is equal to negative the positive 1. Excuse me. So again, this is not row echelon form, but it's close enough. You know, it's still very quick and easy, just like row echelon form is quick and easy. I just got to divide this by 14, and I get my answer. So now I have x. So now I have x. The vector, the column vector, the column matrix x is 1, 2, -1, which means that is the solution to the original equation. So 1, 2, -1. Let's go back to our system of equations. So that's 1 minus 3 times 2. So that's 1 minus 6 is -5. That's 2 minus 3 equals -1, and this is 2 minus 20 minus 2. So 2 minus 2 cancel, and I just had minus 20 equals minus 20, and that is using LU factorization to solve a system of equations. Now it may seem that what we did here is more work and harder and more stuff, and I got to remember all this, but the truth is it's actually a lot easier. It's actually quicker and easier. Now it seems hard because we're not used to it. It's the first time you ever saw it. But once you get used to this, there's a zillion times faster and better than any other method. So that, my friends, is the story. I do have a very nice PDF on LU factorization, which kind of summarizes the whole process. Explains it step by step how you do this whole thing, which is a nice thing I'm just going to give to you. This was actually made up by one of my former students. And it just kind of goes through the process step by step in a very nice, clear, succinct way. I'm going to share this PDF with you all. Well, that's it, everybody. And the next time we see each other, we'll be on the next section. Bye, everybody.